All right, folks, what we're looking at here is a Xiegu G90. This is actually my second one. I picked it up after many years of not having one of these, and I felt very sad about that. So anyhow, we've been running this through some tests and doing some videos on it. And in today's test, what we're going to do is we are going to test the spectral purity of this radio. And that means that when we transmit on this radio, is it emitting any signals or transmissions that would be in violation of FCC rules? So we're going to hook this up to a really fancy spectrum analyzer. We're going to take a look at the rules, and then we're going to test it out. Stay tuned. Elevate your electronic projects with PCBWay.com. Enjoy premium PCB manufacturing and assembly services at unbeatable prices. Benefit from fast turnaround times and reliable worldwide shipping. From initial prototypes to full-scale production, PCBWay.com is your dependable partner. Experience the FT8 and the reason I'm showing the picture of the 3032 is because that's the only good picture that I could find. Now, the 3021 is the exact same spectrum analyzer, it just does not have the same bandwidth capabilities, but it's more than enough for this test. So what we're going to do is we're going to feed a signal into the RF input, which you can see down here on the lower right-hand side of your screen. So for the test setup, what we did is that we have our Xiegu G90 right here, and then we have the RF output coming through this coaxial cable and into what I call the big ass attenuator. The big ass attenuator is a 40 dB pad, and it is good for up to 100 watts. So it's more than capable of handling the power output of the Xiegu G90. After the big ass attenuator, we have a smaller mini circuits. This is the FT8 Plus, and it's a 10 dB attenuator. So the combination of these is going to give us 50 dB of attenuation. If you string attenuators together in a configuration similar to this, you want to make sure that the one with the highest power handling capability is connected to your radio. And then that way the power is decreased, and then the lower signal is reduced another 10 dB. Coaxial cable comes out, and it goes right in here into our RF input. Okay, and here is the front face of the Xiegu G90, which we're not going to see a whole lot of in this video. What we're going to do is we're going to use a CW key here. This is from Morse.us, I believe. It's a 3D printed CW key, and even though I can't do CW, it works just fine. This goes into the key jack on the back of the radio, and then you can see here we are tuned to 28.3 in the 10 meter band, and we are set to mode of CW. And we're going to do this to generate a carrier. Actually here, I'm actually keying up, and you can see down here that the radio output is 20.2 watts. My goal is not to bore everybody to tears, so we're not going to read all of this, but we want to take a look at this first paragraph. For transmitters installed after January 1, 2003, and that's us, the mean power of any spurious emission from a station transmitter or external RF power amplifier transmitting on or at a frequency, it says on a frequency, below 30 megahertz must be at least 43 dB below the mean power of the fundamental emission. So that means if we see any spikes anywhere, they have to be 43 dB below what our fundamental is going to be at. Now, we have things called harmonics, which are multiples of your fundamental transmission. A harmonic counts as a spurious emission, but not all spurious emissions are harmonics. I hope that makes sense to you. Okay, so here's the software that we're going to use to remote control the spectrum analyzer, and it is Easy Spectrum. So there's a couple of different things that we need to do. Is first we want to set a reference level offset, and we're going to set ours to 50 dB because that is the sum of our two attenuators. So we've gone ahead and done that. And the next thing that we want to do is we want to adjust our span. And so I want to go to frequency. And our start is at 0 hertz, which is fine. And our first test is going to be on 160 meters at 1.9 megahertz. And my stop, I'm going to probably set this to something relatively low, like, I don't know, 50 megahertz. And now we're set. So what I want to do now is I'm going to go ahead and I'm going to key up a carrier on 1.9, and we're going to see if there is any harmonics or spurious emissions. And you can see that that is pretty good. Let me go ahead and pause that. And what we're seeing is about 43 dB, which is 20 watts, which is the output power of our test. And so that looks really clean on that. What I'm going to do is I'm going to hit play now, and then we're going to adjust this to 80 meter band, and that is 3.750. So let me go ahead and key up. And again, we see about 43 dB. Let's put a marker on that, and I wonder if I can do that while it's paused. I don't think I've ever done that. Marker type normal, and I'm going to have to unpause, so give me 1 second. Okay, so I put a marker on the top of that peak, and you can see it's 42.56 dBm. And we feel good about that because 20 watts is 43 dB. And again, this looks pretty clean, no spurious emissions that I can see. Okay, now we are set at 7.150 megahertz, which is the 40 meter band. Let's go ahead and key up. And what I did is pause that so we don't have to listen to that noise. And again, it looks like it's at the right power level, and we see no spurious emissions. So I set it to 30 meters now at 10.125 megahertz. And what I want to do is I'm going to come over here. Let me hit play. And I'm going to adjust my frequency. I'm going to go ahead and adjust my scale now, my stop to 100 megahertz. And we're good there. So let's go ahead and key up on 10125. And again, it looks good. No spurious emissions or harmonics that I can see. Let's go ahead and go to 20 meters at 14.175. And again, it's clean and at the appropriate power level, so it's still pretty good. Now we are going to go to 15 meters at 21.225. So let's go ahead and key up. Again, it looks good. Appropriate power level, no spurious emissions or harmonics. And last, we are going to do 10 meters at 28.3. Let's key up. And again, it's clean. So that's really good. I didn't expect that to be as clean as it is, and it looks fantastic, and hats off to Zygu. I want to thank everybody for watching this video. If you have any questions, comments, suggestions, or recommendations, go ahead and post them below, and I'll do my best to respond. As always, thanks for watching.
Hello, my name is Ken, Kilo 9, Kilo Echo November. I'm going to talk today a little bit about Ham Radio Deluxe Band Scope. I know a lot of you people use the program basically for logging or for cat control, but very rarely venture out of your comfort zone and explore some of the other things that Ham Radio Deluxe offers its users. So today we're going to talk about the band scope. There's two ways of activating the band scope. You're looking at the main screen after logging. This is your cat control, and you should have this all set up and ready to go. If you take a look under the view menu, you'll have a various. If you turn that on, it'll bring up this second toolbar down here, and you can see the band scope listed here along with the audio grabber, audio browser, and stuff. There's another way of accessing it up here from the tools. Go to the tools menu, come down the band scope, and highlight it from there. So here we got it on. Let's clear the band scope there. The whole idea behind the band scope is pretty much it puts your radio in a turbo scan mode and will scan the band limits to see what kind or if there is any activity happening on the band today. This goes for a lot of you people who are always saying that there's nothing to listen to or you're getting bored with ham radio because you can never find a cue. So, if you're doing things the old-fashioned way and tuning around and turning the band until you're blue in the face, I can understand that. There's so much space to cover, spectrum to cover, that it is hard to find a cue. So, but with something like like this tool, the band scope, it makes that relatively easy. As you can see, the controls are pretty simple and straightforward. They're kind of like a VCR, forward, backwards, stop, and then you got a couple of configuration buttons down here. I'll show you when we get to it. So let's start this band scope off. We're going to start this on the 20 meter band. I'm going to go right about the middle of the band here to start it, though, because I'm not really interested in what's down here in the digital mode right now, or the digital part of the band. So let's give this a start. You can see the band scope start scanning, and the radio's moving pretty quick here. So I'll give it a second here to finish scanning this. As you're kind of listening, you can kind of hear the QSOs in the background as the band scope is passing over them. It's kind of helpful too. So here we scanned the band, and I'm just going to take your mouse over and kind of look for the high points in the spectrum here. And those high points usually represent QSOs that are happening or where there's activity on the band. Zero in on him a little. Move the line around too and scan up and down the band.
Hi, this is Sean. And you also want to run the digital mode. Do you see what's happening? Just saying from experience. I don't think you have to really be go up and down. You can make all your comments below. Options. This is very deep rooted. This is for actually doing the actual connection of Ham Radio Deluxe to your radio. When you purchase Ham Radio Deluxe, they provide you all that support. You're best to contact them. I'm just going to tune the radio over and press. So traditional. Program options. You can change the look and feel. I have Windows XP because the machine's running Windows XP. I could go Visual Studio 2010 and to give you a flavor of something else is basically the modes themselves. Looking at these different modes, actually, like for example, just to show you, Hellscriber. So we'll do slow hell. It's rather interesting to listen to, and we'll do a CQ. We'll see how it actually comes across. If it actually comes across, it should. Yeah, there we go. There it is. very, very strange sounding. So you just press stop when you're, so let's say you just don't want to do it anymore, it should stop. You have to wait patiently for the stand. It actually has to finish the last character. Look back over to the antenna. PSK31, hoping that there could be something there, but unfortunately there is not. Again, the modes, if I selected all, then of course, I'll show you what it looks like. It eats up the entire screen and your waterfall gets eaten up, and depending on how large your screen is, you might be able to suffice for that. But there's no need to have them all there. I'll just leave that one for now. And it just leaves all these by default. And that's pretty well.
I've used software-defined radios or SDRs before to receive pictures from the International Space Station. I use something like this, a little RTL SDR. This is about $30, I think, off of Amazon. You plug this into your computer, run some software, and you basically got a radio in a USB little package. I've used software such as HDSDR and SDR Sharp, but I've come across something which has completely blown my mind and changed my whole view of using an SDR in my ham Radio Shack. Now, before we get to that, this video is going to be in a series of videos on SDRs and how I'm hertz wide portion really weak 2 bands. The reason is because some of these, such as the AirSpy, can't go down low enough in frequency. You can, if you use something like this, a spyverter, to be able to upconvert to be able to receive HF. The only problem with this one is it's broken and I don't actually know what's wrong with it. So I've been limited to 10 meters and 6 meters. So with all of that in mind, my main goal is I want to be able to receive as low down as possible, receive really weak signals, and I want to be able to, there's other stuff that we can look at. We've got the IF display, so that and adjust the 750 kilohertz and 50. A lot of, but I will show you some of the basics and things that I've been going through to get this running. You can see here that I've got this slice of spectrum here, which is looking at the 3 kilohertz wide portion of FT8 on 10 meters. Now, if I just stop this for a minute, basically once I installed this software, all I did was I just plugged in my SDR and I clicked select radio in here. Go to definitions. You can click search here, and here are a lot of the supported SDR radios. So there's quite a few in here. So just going through, so you've got the RTL dongle in there, lots of SDR plays, and the AirSpy units, and a couple of the others in there too. And I'm sure that you can Google and have a look to see if your specific SDR is supported.
This video is about using an RTL SDR dongle as a PAN adapter for an IC706 MK2G. I have placed a very thin wire 1 turn through this transformer, and I have put some metal piece, lödöra in Swedish, and soldered a coaxial cable on it, and it's sitting on the screw on this
M0FXB, welcome to my channel. External GPS antenna for the Yaesu FTM 500. I have a question here. Where do we buy the antenna? And as far as I can see, you won't find an antenna for sale from Yaesu that connects to this. Now, please correct me if I'm wrong. That's a 2.5mm jack there. Now, if we go to the menu, hold down, turn to 38. The fast way is to turn the bottom knob first, then the top one. GPS device, press enter, and you can select the red at the bottom here, internal, turn it, external. So we're using internal.
Welcome to my channel, FTM 500. Let's do APRS. First thing we'll do is go into VFO mode with here. That's memory, VFO, and we're going to set the right frequency. Now, I have noticed that you do need to be on the right band for APRS. So before we actually do this, we're going to hold down the F button, go to APRS modem, and we're going to turn it on, 76, push it. Now, if you hold it, you can create a shortcut. We're going to push it, and at the bottom it says off, and then we're going to turn it so it says on, then we're going to back out completely, and what we want to be looking for is A12, and can you see it's put it on the B section. So what you do now is press the up and down arrows here, and it puts it on top, and then we need to set our frequency now, because otherwise, I can't actually see a thing that tells you if you're on the main or the subband. Right, so what we're going to do now is go to VFO, and then we're going to type in the frequency. I use the microphone, it's a lot quicker. 145800. Okay, and that's the correct frequency in the UK for APRS. Also, you can hold your finger down, like so. You can just type the frequency.
Hello, everyone, and welcome to another episode of BC Plus Live. I'm your host, Jeremiah, W9JEM, and I'm joined by my co-host. And if you're not seeing APRS and other settings in APRS, the first thing to check is go over here to Tool, go to Options, and make sure your GPS is turned on, as well as APRS and APRS analog receive. You want to make sure those are turned on. Because I have Bluetooth and I have the BTO1 microphone, I have both of those enabled as well. And I am running firmware version 2.08 as well as CPS version 1.21. So we'll come over here to where it says APRS. And here's our pop-up window. Now, right now, manual transmit intervals is set to 5 seconds. APRS auto transmit intervals is set to, I believe that's 5 minutes and 45 seconds, which seems a little odd to me. Why I have it set for 5 minutes and 45 seconds, so I'll just change that back. Support for roaming on. This one, you can turn it on or off. It really is up to you. I don't use roaming for mine, so I don't use that. Fixed beacon location. Because I'm at a house, I can actually take and put in the correct longitude and latitude, which is not correct on here. But I do have my GPS antenna outside, and I do have a GPS fix. So I can actually take and turn that to off. And then if you want to hear the APRS transmit tone on analog, you can turn that on. I leave it off. And for the 578, this is actually going to be APAT51 for the 578. Now, Andy, correct me if I'm wrong here, but really is up to you. I don't use roaming for mine, so I don't use that. Fixed beacon location. Because I'm at a house, I can actually take and put in the correct longitude and latitude, which is not correct on here. But I do have my GPS antenna outside, and I do have a GPS fix. So I can actually take and turn that to off. And then if you want to hear the APRS transmit tone on analog, you can turn that on. I leave it off. And for the 578, this is actually going to be APAT51 for the 578. Now, Andy, correct me if I'm wrong here, but the default should be 0 for mine since I'm a fixed station, correct?
Correct. Since you're not moving around.
In my car, that would be the SSID for mobiles.
Which one was it?
The 2-call SSID.
Yes. That's where you make those changes.
All right. And then under your SSID, I need to set that one as 0 as well.
Yeah. 0 is your primary station, usually used usually fixed in messaged cable capable.
All right. And then APRS map icon, there's actually a website that has a list of the different map icons in the symbol tables. Let me see if I can grab that real quick.
Yeah, I've got the one that's got none of the labels, but it does have the numbers. It's 0 through 15.
Okay. Let's see. Bear with me for just a second here. So for mine, I am on the table that trying to see where this actually is here. Because these have honestly always confused me on setting up the house. Because somebody told me once I had my house moving down the interstate when I was in my car. And I'm like, I don't have an RV. So
at least not yet.
That's a long way off. All right. So APRS symbol table is going to be the S. Or the slash rather. And then let's see here. There's a few different websites where you can get these from. Andy, do you have a particular one that you recommend?
For which for pulling up the IDs?
Yeah, because I want to make sure I show them the right ones on the first try here.
No, I don't have a particular one that I fancy on a regular basis.
Okay.
Let's see here.
You who noticed, I am running version 1.20 for my CPS, and my radio is running firmware version 2.07 on my 578. That is for the 578 UV3 Plus radios. If you're running a 578 UV3 Pro, it's going to be version 1.20 for your firmware. All right. And then here in a moment, we should see it beacon on the APRS because it's already got a GPS lock. You who noticed, I am running version 1.20 for my CPS, and my radio is running firmware version 2.07 on my 578. That is for the 578 UV3 Plus radios. If you're running a 578 UV3 Pro, it's going to be version 1.20 for your firmware. All right. And then here in a moment, we should see it beacon on the APRS because it's already got a GPS lock. That's one of the things Anytone improved on the 578 and the 878 software is how fast it gets the GPS lock now.
What's your SSID?
SSID is W9JAM-6, I believe. Now you'll see that it's showing that there's a repeater right here, a digipeater with my call sign. That is actually my custom-built iGate.
It's not good.
All right, it just beaconed. So if we search for W9JAM now.
Yep, there you are.
W9JAM. It'll show the list. And then we see the -6 right here. So if I click on it, there's my location right there. That's the way APRS should come across. Is it should beacon out, the digipeater picks it up, and then reports it to the network. And it shows the information, APAT51, indicating it's an Anytone. And then the wide 1-digipeater. So give me 1 second.
It shouldn't come through the local digipeater. It should have routed back through your. It should know to go backwards because the iGate's a one-way. I'm pretty sure that.
Hi, this is Dwayne N6DMR. This is a redo of APRS send video. The last one I did last week it was a little bit too blurry. So basically I wanted to make sure I redid this so that it was much easier to follow. I appreciate all the comments I got. They're very helpful. And I definitely want to make this a video of a higher quality. Okay, thanks again, and please hit the subscribe button. It would very much help me if you could. Everyone's trying to build their channel. I'm trying to build mine. I'm rejuvenating this right now, so I'm going to expect a lot more and current videos and a lot of tips and tricks videos as well. So thank you again, 73. So moving on with the tutorial, going to do a little quick overview here of the APRS menu. This section in red right here is a common settings. They're your default settings for timing of auto and also for push to talk and many other things. I'm going to go over them in detail, but this section right here pretty much applies to both analog and digital equally. So a couple things when we get into the details, I'll go over them. The section right to the right here, this is your digital channels. And basically the talk group that is assigned by Brandmeister for APRS is 310.099. I filled out all 8 records this way. No big deal. This particular activation delay is part of the digital side. This block below, this section here, it says it's analog, but unfortunately, it's not quite true. Many of the edits that are going to be doing in here are going to actually be applying to either digital or analog when it goes out, call sign, etc. This is the analog frequencies that will be sent to the background of any channel that you have. And in this particular section here, this is receive information for setting the radio up for APRS receive. So hopefully that this overview will help you and give you a little bit of understanding of how the menu is laid out. And I'll leave it up for just a few minutes. Sometimes people like to copy, and then we'll move on to the next session here. Okay, moving in now, this is moved out here. This is the APRS menu again, except this is a live menu. I can make changes to it. I have a channel menu over here, because both of these are tuned together. You can't have APRS sending without sending on a channel, but I am going to go over everything here. First section, let's look totally at some of these timing settings. So you have a manual transmit interval. Okay, and what that is when you press to talk on a channel like this one over here, where you have it's set up for APRS. When you press to talk, it will send a signal, APRS signal in the background. You'll get the pop-up menu that the packet is going out, and it'll continue doing that every time you press the push to talk until you put a timing set in here. I have it set for 30 seconds. So the way this works is the first push to talk will go out with an APRS. If you push to talk within and 30 seconds has not expired, no APRS will go out. If you push to talk after the interval set here, then you would get another APRS send manually, and you can continue doing that. Typically, I don't basically think that you need to set this any more than 30 or 60 unless you're having a long QSO with someone while you're sending, and you don't want to send every 30 seconds or 60 seconds, and then you would want to put something longer on there, up into the 120 or as close as you can get to 2 minutes. And there they are right there. Okay. And what that means is how that would work is you'd press the talk, APRS signal would go out. You could continue a QSO talking, push to talk again and again. It will not send another manual transmit until 120 seconds have elapsed. A very, very simple thing. The reason I brought this channel picture up here that I want to save for you guys and show you, I'm actually going to do a quick setting now. You must set a channel to transmit APRS. I'm sorry. It does not have to be a digital or an analog channel. It could be either one. You can choose. This happens to be a digital channel, but I'm going to choose the APRS report type as analog. So the analog, it's going to go out in the background as analog. I'll set the push to talk mode at end of transmission, and I'm going to put the report frequency on number 1. And when you set these three sections of the channel, when you turn to this channel and you have this channel on an active VFO, A or B, and you press the talk, this is going to initiate APRS. Now it's going to do it in 2 ways. First, as we said, on the manual transmission side, it will send, and I've chosen here end of transmission. So when you key up, you're talking. When you unkey, it will then send an APRS manual transmission in the background. And these are going to be going out to the channel 144.390, which is the US APRS analog frequency nationwide. Okay, so this is how the channel and the APRS menu interact. I'm going to leave this. This is probably going to pop up and down as I move between the screens, but as I need to, I'll be bringing it back up. So let's move into the next, which is your APRS auto transmit. Okay, I have the interval set here at 120. It will then send it to you and an APRS send. A lot of times I'll if you so often. Sometimes that can be awkward. If I bypass, make sure you want to put who call is. There's only two things that should be going in here, APA. Leave this, this is probably going to pop up and down as I move. As we said, on the manual transmission side, it will send, and I've chosen here end of transmission. So when you key up, you're talking. When you unkey, it will then send an APRS manual transmission in the background. And these are going to be going out to the channel 144.390, which is the US APRS analog frequency nationwide. Okay, so this is how the channel and the APRS menu interact. I'm going to leave this. This is probably going to pop up and down as I move between the screens, but as I need to, I'll be bringing it back up. So let's move into the next, which is your APRS auto transmit. Okay, I have the interval set here at 120. This auto transmit, this will send an APRS signal when the GPS is on and you have a GPS lock, meaning that the GPS location data is available to send. Once that happens, you set the interval that you want it to go out on. As soon as you turn to this channel and you have it set that way, it's going to start sending an auto APRS at the interval that you set. Now, when I'm testing, a lot of times I'll make it 30 seconds. I think the 578 only has 60 seconds, but I shorten the interval just so that I can make sure I'm getting good packets and I can watch them come in on APRS FI. All right. There's support for roaming if you need it. If you have roaming set up, you can choose this and turn this on, and APRS will send even if you're doing roaming channels. Leave it off for now. I don't do roaming very often. Now, the next thing we're going to talk about very quickly here is the fixed location beacon. It's off right now, meaning that it will not send a fixed location beacon. It's going to send the auto transmit, but it's only going to send it again if the GPS is on and you have a GPS lock. Now, sometimes that can be awkward if you're doing testing. So I will turn this on, and when you turn fixed beacon on, you won't have an auto interval. It's just going to send the fixed beacon at the same interval, but it will not have the GPS coordinates. It's going to have the coordinates that you load down here in the latitude and longitude. So once that's on, this becomes active. You can go in and make changes to it. You would put your latitude and longitude for whatever the location is that you want to send. And this is going to send a fixed location no matter whether you move around or not. I like to do this, like I said, when I'm testing. I can bypass having to have the GPS lock, and I can test to make sure that the code plug is sending packets properly and they're being received by APRS FI. Now, a couple of things with this: when you put in your latitude, make sure it's a northern for the U.S., and when you put in your longitude, make sure it's eastern for the U.S. Now, a lot of times you'll see this written as -113 or minus longitude, and that actually equals east. If you set this to west, your beacon will be somewhere out in the China Sea, which I've done already a number of times as I've been playing with this. Okay, so once you turn beacon off, fixed beacon off, you can no longer make changes. So just so you know that. But you will be, once you get a GPS lock, you will be starting to send the actual GPS location as you move around. Okay, so that's generally, this is working for not only analog, but it also applies to digital, all these settings here. Now, down at the next block, it actually says analog. However, it kind of is, it is a little bit of both, actually. So the APRX transmit tone, this will allow the radio to send a loud tone of the packet, burring sounds going out as the packet if you have it turned on. A lot of times when I'm testing and I'm not going to be looking at the radio and I want to hear the packet go out so I can watch it come in on the APRS FI website, I'll leave this on and I'll know that I'm sending by listening to the tone. It gets real old fast, so in general use, I would say you would probably be turning this off, leaving it off. Now, to-call. To-call is a actual setting that is documented in a database, and it's an APRS database. Originally, it was developed and kept up by Bob Roinga, who's known as the father of APRS. Bob passed away this past year, I'm not exactly sure who's maintaining this, but I know that someone is based on the APRS.org organization. So what this is here, to call, it's assigned APAT81. That is the Anytone 878 to call. This is what you want to put in there if you're running an 878. If you were running a 578, it would be APAT 51 for the 578. What to-call does is it buries itself in the packet information going out, and when you receive it, if you have the decoding and you know what to look for, this will tell you that it's coming from an Anytone radio. Basically, it's because of different capabilities of radios. What you also need is a SSID. I always use one. I've seen a lot of times the default from Anytone will be 0. That will work. I personally like to use 1, so that's the way I set it. It's a personal thing. So that's what to-call is. There's only 2 things that should be going in here: APAT 81 for the 878 or APAT 51 for the 578. Now, in your call sign, that's an obvious thing. You'd put your call sign in here, and then also choosing a dash number SSID. Now, what I like to do, because I have multiple radios, I will assign the radio a number, and I will use that number as my dash. And what that allows me to do, when you're in APRS FI and you're searching for your call sign and your packets, you can put your call sign with the dash number in there, and that's going to bring up what you've got set here. You put the -1 in, it's going to bring up the -1. Now, if you're sending it -1 and you put in -2, you're not going to see any packets. It's not going to recognize it. So that's how this works. APRS symbol table, that is a chart table that will show you basically icons that will show up on the APRS FI map system. And for every icon, there will be a character. And the character is what you put in the next line down here. So the symbol table I use is a /. That's the standard symbol table. There is a \. There may be a third one. I don't follow that closely. But personally, I use the standard table. It seems to work and be a lot more reliable than some of the other exotic icons. In my case, I don't choose a physical icon. I choose 1, so that when my packet comes in, it will show 1 on the map, and I know that's my number 1 radio location. If you choose a different icon, ampersand, or one of the others, it could show that you've got a certain weather station, or it could be a home, picture of a house, things like that. And so it's very, very polished. I can't really go into it in detail right now, but if you Google APRS icons, you will get a lot of information, and it's very easy to understand. Charts are usually in color, and they look pretty cool. All right, next thing you need to set is the digipeater path. Now, receiving APRS signals in the United States, there are 2 types of receivers. One is an iGate, which does nothing but receive, and it will not pass or bounce your signals anywhere else. It will receive it, and if it does receive it and it's connected to the internet, it will post your packet on APRS FI the way you're supposed to, and your location will show up. If you're sending and your signal reaches a digipeater, the digipeater will also send the signal and the packet to APRS FI, but it will also bounce the path so that you have an extra location, and maybe another beacon will grab it and also post it. Now, I don't really worry too much about this. I have not had any trouble with digipeaters or iGates. As long as I know where they are and I know that I'm within their location, I don't have a problem. So what the settings here are wide settings, and you can Google those as well. What's recommended is most common is 2 signals, wide 1-1 with a comma, and then wide 2-1 afterwards. You can have more than 2. You could have 3 or 4 wides. Just make sure they're all separated by a comma. That's very, very important. You miss out that comma and your packet's not going to be going out right. Okay, entering your sending text. In this tutorial, I put APRS tutorial, my call sign 878 and analog, and that information will be sent in the packet. It will be decoded, and if you go into APRS FI and go from the map icon to the actual packet listing, you'll be able to see that information in the packet. As far as the transmit bandwidth, I use narrow. It's a personal choice. Wide works. Narrow, I feel narrow is adequate, and so that's what I normally set. Now we have some delay stuff in here and a couple of other issues that we should go through. Transmit delay in milliseconds. Anytone recommends this at this point that you would set that at 1200 milliseconds. I've used anything from 600 milliseconds on up, and I've never had a problem. But as we develop the system, Anytone is recommending a higher delay at 1200, which is why I'm setting it this way. Now I'm going to skip down here to the pre-wave time, also in milliseconds. Again, Anytone's recommendation is 1200, and that's the setting that I would use. Now, moving back up on what I didn't cover to skip over, this is a send subtone, and it's off. What this does is if you have a local repeater that you're set up to accept APRS, all right, in say an event, a race or an event or a bike race, things where you're actually manning checkpoints and things like that, a lot of clubs will put up their own repeater, and they'll, in order to keep the packet signals coming in and not having the repeater annoyed with direct signals coming in without it, they'll set this tone to either CTC, which is PL